Hi, my name is Maswan, and today we're going to be discussing SSH and Active Directory. SSH stands for Secure Shell. It's an open source network protocol that is used to connect local or remote Linux servers to transfer files, make remote backups, remote command executions, and other network-related tasks through SCP or SFTP between two servers that are connected on a secure channel over the network. The SSH is organized as three protocols that typically run on the TCP. We have the Transport Layer Protocol, which provides server authentication, data confidentiality, and data integrity with forward. The transport layer also can provide compressions as an option if you wanted to. We also have user authentication protocol, which provides a way for the client to be authenticated to the server. In the user authentication protocol, there are three types of messages that are always used. We have string username, string service name, and string method name, which is the method specific fields. We also have connection protocol, which multiplexes multiple logical communication channels over a single underlying SSH connection. And the SSH default port is TCP port 22. OpenSSH is the leading connectivity tool for remote logins with the SSH protocol. It encrypts all traffic, including passwords, to eradicate eavesdropping, connection hijacking, and other attacks. It also provides a large suite of tunneling capabilities, several authentication methods, and sophisticated configuration options. It is also the standard SSH client and server used by most Linux distributions. It's a connectivity tool that most administrators rely on to work on their Linux and BSD servers. And OpenSSH uses ciphers such as AES, Blowfish, and 3DS for secure encryption communication. With the SSH configuration files, you have the OpenSSH server configuration file, which is found at SCSSH, SSHDconfig, and you also have the OpenSSH client configuration file, also found at the SCSSH, SSHconfig file, and you have the user SSH configuration directory, which is found at .ssh. And also you have the list of the public key RSA or DSA, and that can be used to log on to the user account, and that's found on the SSH authorized keys configuration file. We also have the file that only allows root user login and blocks everybody else, and that's etc no login. We also have a file where you define access control list that should be enforced by TCP wrapper, and that's on etc host allow or host deny. For SSH best practices and hardening recommendations, it's always a good practice to have a firewall, and that's one of the best practices used to block access to SSH unauthorized IP addresses. And you can also use VPN to provide secure access to the system from those users that are remote access users. And if you do not have any hardware firewall, you can use IP tables to limit the SSH access. Also use public-private key pair for authentication instead of the password. And you can do this by generating a password protected SSH key for every computer that needs access to the server. And to permit public key SSH access from allowed computers, you can copy content from SSH ID RSA pub from each computer into the individual lines of the authorized key on the server, or you can run the SSH copy ID with IP addresses on every computer that you're granted access to. Also, to disable password SSH access, you can open the etc SSH deconfig file and find the line that says password authentication yes, and you can change that to password authentication no. And then after, of course, restarting your system, that will apply all those changes to the firewall. And after doing that to the system, and after doing that, the only way the user can use the system is to use the key that matches a line in the SSH authorized key, and this helps in the prevention of brute force attacks. You can also use fail to ban to prevent the brute force login attempts. And fail to ban is a log watcher daemon that monitors any repetitive failures and blocks the source IP address using IP tables. And it's distributed with most of the bundles, and you can enable it by uncommenting the SSH part of the fail to ban configuration. And also it's recommended to disable login as root via SSH, because normal users should use su or sudo to gain root level access, and therefore should not be giving root access via SSH. And doing this will allow you to also get full auditing information about who ran what commands on your system using sudo. And to disable root login via SSH, you can add the permit root login no to your etc SSH deconfig file. And also you need to limit users SSH access by either groups or just specific users. And by default, all system users can log in via SSH using their password or public key. They have therefore they have full access to the system tools, and to only allow certain users to the system via SSH, you add the line add allow groups or allow users, and you just specify the groups or users that you want on the system to limit who can access SSH to the server. Or you can also allow all users to log in via SSH by deny only a few users by using the deny user command. Also, you can use the TCP wrapper, and which is a program that you can use to specify a list of IP addresses that are allowed or denied to access the SSH server. And you can use that using the etchost.allow and etchost.deny files. And it's also a good security practice to add your own IP address to the etc.allow command so that you don't lock yourself out of the server. Also, it's recommended to use deny host, and that allows organization to monitor invalid login attempts and block the originating IP from where the authentication requests are coming from. You can enable this layer of protection by installing deny host package using apt-get command, and then configure the deny host configuration file and change the SMTP settings to allow sending emails to administrators after blocking certain IPs. Another best practice is to disable forwarding. And port forwarding is when you can tunnel network connections through an SSH session and specific graphical application through an SSH session, and that's enabled by default. and disabling this option gives you a little bit of security. And you can disable forwarding by going to SSH config file and look for allow TCP forwarding yes and X11 forwarding yes, and replace them with allow TCP forwarding no and X11 forwarding no. And also you can minimize text surface, and by default the OpenSSH GIF tool needs to allow users to authenticate and allow themselves up to 6 authentication attempts. And to minimize the attack surface, you can reduce these values by updating the SSH config file with login grace time. You can put like 30 minutes maximum authentication tries to 3 minutes, or based on your company policy, you just look what the policy says about minimizing the attack surfaces. Also, you can mitigate a privilege elevation, and this prevents users from being able to set environment options through SSH connection and potentially break some access restrictions. And you can do this on the SSHD config by putting permit user environment here no. And also, you can do privilege separation to prevent privilege escalation by containing on any corruption with the unprivileged processes. You can also do this in the SSH config files by using privilege separation yes, and you can also use the strict mode yes for file permission and ownership of user file checked before accepting a connection. Active Directory is a directory service that's developed by Windows for the Microsoft Domain Network, and is included in most Windows Server's operating system as a set of processes and services. It plays a vital role in Windows networking, and is designed especially for distributed networking environment. And it's a centralized and standardized system that automates network management of user data, security, and distributed resources, and enables the interoperations with other directories. It uses the Active Directory security model, which is used by administrators to protect their directory from attackers and users while giving tasks to other administrators where necessary. And the Active Directory security model associates an access control list with each container, object, and object attribute within the directory. And we also have the Active Directory architecture. And for user or administrator, Active Directory provide a single hierarchical view where you can access and manage all of the network's resources. There is the security subsystem, which runs in user mode. And user mode applications do not have direct access to the operating system or hardware. Requests from user mode applications have to pass through the executive service layer and must be validated before being executed. And being part of the security subsystem makes the Active Directory an integral part of the access control and authentication mechanism built into the Microsoft Windows servers. Access control and authentication protects the resources in the directory. Each resource in Active Directory is represented by an object. Anyone who tries to gain access to an object must be granted permission first, and a list of permissions that describe who can access an object, who cannot access the objects are referred to as access control list. And each object in the directory has an associated access control list. You can also use group policy to restrict permissions across a broader scope. And the security infrastructure for Active Directory uses policy to enforce security models on several objects that are grouped logically. You can also set up a trust relationship between groups of objects, which will allow an even broader scope of security controls between trusted groups of objects and that need interaction. And for best practices for Active Directory, first we're going to be looking at implementing a secure Active Directory administration model. And this restricts the use of domain administrator accounts to domain controller and to prevent the likelihood of privileged AD credentials being compromised. And also I have physical security, and that's very vital to have adequate physical security, because if a hacker can just walk into the building and pick up a domain controller and walk away with it, and then it gives them access to the Active Directory database and access to user credentials. And if you are in a situations where you feel like you don't have enough access, physical security, then you can use the read-only domain controller, and which does not store the user credentials on it. Also, for security hardening, you can use protected user group, which adds boundaries that are designed to lessen the likelihood of compromise. For example, by blocking the use of Microsoft Legacy Authentication Protocol. And also you can use authentication policies and silos that also can be used to restrict the device that a user can authenticate from. Also, there is a security configuration wizard that can be used to develop a security policies, and it uses a set of predefined questions and analyzes your current environment based on those answers that you put on those questions, and then it automatically generates a group policy object that can be used to secure your domain controller. Encryption, signing, and authentication. Windows Firewall includes the ability to create IPsec policies for encrypting traffic between endpoints. And this is a very tricky process, but it's doable with careful planning. And we also we need to mind the domain name system. It's important to integrate the domain name system and Active Directory, and there are 2 rules for DNS naming convention that should be followed when creating an Active Directory domain. The rules are 2 children domains of the same parent cannot have the same name. A child domain can only have 1 parent domain. And if your organization uses the internet, the name of the forest root domain should be registered. And Active Directory requires that DNS server support service resource record. And the service resource record records maps domain controllers to network services. Thank you for listening.